Hi, I'm Jack, and welcome to Doing Shit Required for Class. So today we're going to be solving this problem from exam 2 that a lot of people had a problem with. So let's start. I have all the important information over here, highlighted, underlined. So the first thing it asks us to do is draw a clear free body diagram. So based off of the image and the information we're given, we're going to start with the skydiver. So we have our skydiver. Let's see, the first force that identifies is a horizontal drag force. Now we don't know the direction this is going. Based off of the image, I'm just going to take a guess, and knowledge of planes, that it is pointing left. But if you don't have that image, you can solve for it. And we're going to call this D for drag. And then we have a tension force in the arms that is 21 degrees from vertical, and we're going to call this T. And then we have a gravity force, or a weight force, that's what we'll call it, pointing straight down. So looking at this, the only force that we know based off of this information is the weight. The only force we know is the weight, right? And the weight points straight down in the negative y direction. So to calculate the weight, we take the acceleration due to gravity, so weight equals 9.8 meters per second squared times the mass of the skydiver, which is 83.0 kilograms, right? So weight is equal to 813 newtons. So knowing that, and knowing that it only points in the negative vertical direction, we're going to do the sum of the forces in the y direction, which will be equal to negative W, since it's pointing downwards, plus the vertical component of T, which will be the cosine of 21, which is that adjacent side of that triangle, times T. We'll just put T there, which will be equal to 0, since it says that the skydiver is stationary, as I have underlined. Knowing that, we can solve for T. We'll say T equals to W over cosine of 21, which equals 871 newtons. So, or about 871 newtons. So knowing that, we now have one of two forces that exists in the x direction, so we can find drag. So we have our sum of forces, F, in the x direction, which will be equal to negative drag, or negative D, plus the x direction of T, or the sine of 21 times T, which will also equal 0. Now we know T, so in order to solve for D, we just move it to the other side, and we say D is equal to negative sine 21, positive sine of 21. We'll just make a little plus sign. T. So We know T is about 871 newtons. So D will be about 312 newtons. And that's using the rounded values.